Hello. In this video we're going to go through a more complex mapping, one that involves storing a struct. For the struct I've set up this user info, which contains two uints, one boolean and one address. And we'll also delve a bit into bitwise operations. So let's move to the UL contract, and here I've stored one struct inside the mapping where my address is. I've also commented out the deposit function from the simple mappings exercise so that we have a comparison, and I've prepared the assembly blocks. So let's get started. And first things first, let's remember how we got the storage location in a simple mapping. Well, we used to run kcheck256 on the msg.sender and the slot of our mapping, and this is exactly the same. We're just going to repeat that, except this time I'm going to use the memory slot 0x0 so that you guys don't think I'm running a trick on you with those 0x40s. Now let's move on to the second slot, and here we're going to use the user infos.slot. And lastly, let's call this data location, store the kcheck256 of these two slots. And now we have the storage location of this struct here. And you're going to be like, well, okay, but how are we going to get all these individual values? Well, we are basically pointing at the start of our mapping. You can also see this mapping, and this is how I sometimes like to imagine it, as an array. Basically, salary is at index 0, age is at index 1, is active as index 2, and so on. And essentially, you just move to the pointer where this variable would be. So, to be more explicit, let's try to get the salary. And we want to load the pointer at location 0, which is basically data location. And now let's move to the age, and here we would need to move it by one position. So we would have add, and to the data location we add 1. And then let's get is active, and we would load at the position number 2. And lastly, we have backup address, and we would load it at position number 3. And now let's deploy it. Let's get the user info, and we notice that we're getting the 0 address instead of our address. So what is happening? Well, essentially, in memory and storage, one slot has 32 bytes, but the boolean has 1, the address has 20, together they have 21, and essentially they're on the same slot. Using absolutely all my design skills, I prepared this to visually explain where the problem is. So this is one storage slot, this is where the boolean is, this is where the address is. So they are in the same slot. And well, how do we get them from the same slot? Well, technically we need to change this to 2, but of course this is incomplete. What we need to do here is essentially to get the backup address starting from the second slot. So basically we need to run it using a bitwise operation by 8 bits from the right. So that would be shr and 8 and sload, and that is it. So remember, this is bits and these are bytes, just to clarify that. And now let's redeploy this, and when we're going to run get user info, we will see that our backup address is fine now. But there's still a problem. You maybe didn't notice it the first time, but this isActive is returning true, and we have it set as false. And why is that? Well, because the isActive is still loading the full storage slot. Okay, how would we fix this one? Because we can't move it to the left or the right. The isActive is exactly at the start. Well, we would need to do a bit masking. And in order to do that, we need to set up one byte rather, and we'll use the 0xFF for this, which you can imagine this as being 1, basically. And in order to return the value, because we need a boolean basically, we need to run these two in an AND instruction rather. And let me explain what this is doing. So if this is 1, the result here, the result in the first byte, if this is 0, we know from the AND operations that this will return 0, which is false. If this is 1, 1 with 1, and the AND will return 1, which is true. So let's redeploy this, and when we get the get user info, we are getting false. This is correct. So we are actually done with the user info, with the get user info. So let's move on to the set user info now. And well, first things first, let's get the address. Let's get these 3 lines basically. Let's reuse them. And now what we need to do is to start storing the values at these data locations. So how would we do that? Well, store and data location, this would be salary essentially, and then at the location number 1, like we have here, we would save the age. So just like in the get user info method, we are going to go through them one by one, and just but this time we'll store them. And then here at the data location 2, we would store is active. But well, actually let's stop here, because you know where I'm going to go with this. We can't store them just like this. Again, we will have a problem with the fact that they are on the same slot. So what we need to do here is essentially build one slot from 0 and store them both there, and then store whatever we built on that slot. Okay, let's call this packed slot. Let's call it here, let's call it packed slot. And what we want essentially is to put the is active here first. Basically, we want to have it in the first byte, right? Well, we can't really run it exactly like so, because we need to convert it in bits, or bytes rather, and we would have to put it at the 0 position here. And this is how we are going to start with it. And now we need to add to this the backup address, right? So to packed slot, we have to start the backup address from the 8th bit, right? Because if you remember, we have to this time move it from the left, right? We need to move it from the left. So we would have 8, and we would have backup address. Well, this looks fine and dandy, but this is not the correct solution. And why is that? Well, because we need to put them on the same slot. We're basically doing a reassignment here. So for this, we will need to use another operator, and in this case we will use OR, and we need to pass it two values. The first one we will pass it packed slot, and the second one will be this. Okay, so what are we doing here exactly? So in the first slot we have this is active, right? And from the first slot we have this backup address. We are running OR because what we will have is, on the first slot we'll have this is active and essentially 31 zeros, and this second one will basically be an empty let's say 0 or empty byte here. Then we will have the address, and then these will be empty as well. So when the OR happens, if you know with OR, if one is true, then the result is true. So we will have basically true on these 21 bytes, and in the end we will get the correct result. And of course here it is not is active, it is packed slot. Okay, so let's deploy this, and let's set the user info. I'm just going to set myself up again. So here we had 3000, 20 and false. So let's say 4000, 30 and true. And we should let's transact, and when we get the when we use the get user info, like so, you will see that we are getting the correct values. I hope that was not overly complicated. I maybe haven't explained all properly, but for bitwise operations, there is a channel I've found, Rian Block. I'm going to leave it in the comments. I think he has great videos on this topic. But the main purpose here was actually how to deal with the mappings, with the struct in the mappings. So that is what I mostly wanted to show, not the bitwise. And that is it. If you have any questions, please leave them in the comments or DM me. Thank you for watching and see you in the next videos.